The first set of questions in our assessment task relate to gas reactions and volumes, and that means they relate to Gay-Lussac's law and Avogadro's law. And these two laws are here, and they're also in your notes. Gay-Lussac's law says in gaseous reactions, the volume of the gases that react and the gaseous products are in a simple whole number ratio to each other. And Avogadro's law says equal volumes of gases contain equal numbers of molecules. Well, what does that mean in the applied situation? So let's take an example of an equation that we would have used and balanced in the past, something like nitrogen gas plus chlorine gas turns into nitrogen trichloride. And when you balance that equation, you see that one nitrogen molecule reacts with 3 chlorine molecules to make 2 nitrogen trichloride molecules. Well, how does that relate to these two gas laws? Because these are 3 gaseous chemicals. Well, what it means is that here you go, one nitrogen molecule is reacting with 3 chlorine molecules to make 2 nitrogen trichloride molecules. And what Avogadro's law is saying was that equal volumes of gas contain equal numbers of molecules. That means effectively this one molecule will take up 1 unit of space, these 3 molecules will take up 3 units of space, and these 2 molecules will take up 2 units of space. And obviously from the reaction itself, one molecule reacts with 3 molecules to produce 2 molecules. So if we look at it from the equation, 1 molecule of nitrogen plus 3 molecules of chlorine turns into 2 molecules of nitrogen trichloride. That's pretty obvious. From Gay-Lussac's law, that also means that if you react one volume, whatever you say one volume is, that one volume of nitrogen reacts with 3 volumes of chlorine to produce 2 volumes of nitrogen trichloride. So there's a nice simple volume relationship too. If you're dealing with volumes of gases, there's a nice simple relationship there as well. And down to Avogadro's law, by relating volumes of gas to actual numbers of molecules, we can say that a certain number of molecules or a certain number of nitrogen particles reacts with 3 lots of those nitrogen, 3 times that many particles of chlorine to produce 2 times that many particles of nitrogen trichloride. And moles is the way we count particles or count numbers of particles in chemistry. So we can say 1 mole or 6.022 by 10 to the 23 particles of nitrogen reacts with 3 lots of mole, which is 3 lots of 6.022 by 10 to the 23 particles of chlorine to produce 2 moles of nitrogen trichloride. And that mole situation is going to become very useful as we go along. As long as you can see from this picture that when molecules react, they react in simple number ratios to each other. And the mole is just a counting number, so it's just a way of counting particles. So it could be 1 dozen nitrogen molecules react with 3 dozen chlorine molecules to produce 2 dozen nitrogen trichloride molecules, except there's so many particles reacting in chemical reactions, we use such a big unit as the mole. Let's see how this question 1, relates to these 3 laws. Well, first of all, we can say, let's go back a step. From the equation, we've got the volume ratio. If we wanted to write it in ratio form, we could write nitrogen to chlorine to nitrogen trichloride. The ratio there is 1 to 3 to 2. For every 1 nitrogen volume, we have 3 chlorine volumes and produce 2 nitrogen trichloride volumes. Or, another way of writing that is the volume of nitrogen divided by 1 is equal to the volume of chlorine divided by 3, which is equal to the volume of nitrogen trichloride divided by 2. And that little relationship there, by putting the actual fractions of the ratio underneath each one, it's going to make us solve some problems a bit easier later on. So here we go, question 1, example 1. Question 1a says if we've got 100 mils of nitrogen, so we've got 100 mils of nitrogen gas, how many mils of chlorine gas react and how many mils of nitrogen trichloride do we produce? And mils is a measure of volume, so we can use Gay-Lussac's law, that simple whole number ratio law. And we've got this nice little ratio here. We can say, if we're trying to deal with chlorine, we can say, well, the volume of nitrogen divided by 1 must be equal to the volume of chlorine divided by 3. And we know the volume of nitrogen is 100 mils. So we put this here, volume of nitrogen divided by 1 equals volume of chlorine divided by 3. And obviously that's 100 mils divided by 1 because we've been told the volume of nitrogen equals the volume of chlorine divided by 3. Now anything divided by 1 is just the same thing. So that line is exactly the same as saying 100 mils equals the volume of chlorine divided by 3. Now to rearrange our equation, we're going to get this 3 off the bottom. We're going to times both sides by 3. So by timesing both sides by 3, we get the volume of chlorine is 3 lots of 100 mils, or just 300 mils. And that's pretty easy to see just from the ratio, because the ratio is 1 to 3 to 2. If you've got 100 mils of nitrogen, you're obviously going to have 300 mils of chlorine just by the ratio. But the reason we're going through the steps in the ratio is because sometimes you won't have nice easy numbers like 100 mils, so we're going through the process. Let's continue that example though. Let's see if we've got 100 mils of nitrogen, how much nitrogen trichloride do we have? So from the ratio, the volume of nitrogen divided by 1 is equal to the volume of nitrogen trichloride divided by 2, based on that mole ratio, which we've got written here. We can now start substituting some things in because we know the volume of nitrogen is 100, so 100 mils divided by 1 equals the volume of nitrogen trichloride divided by 2, or 100 mils equals the volume of nitrogen trichloride divided by 2, or the volume of nitrogen trichloride equals 2 lots of 100 mils equals 200 mils. And that's our first simple mole style example looking at actual mathematics in chemical reactions. But we can start making these equations a little bit trickier by not having nice simple numbers like 100 mils. So this time we've got the volume of chlorine is 1.5 litres. And so we're trying to figure out the volume of nitrogen that reacts with 1.5 litres of chlorine. So this time we know the volume of chlorine, so we're going to be dealing with volumes of chlorine all the time. So let's try to find the volume of nitrogen first. And we've got this nice ratio from the top here. The volume of nitrogen divided by 1 equals the volume of chlorine divided by 3. We can now substitute in, because we know the volume of chlorine, which is 1.5 litres. And we can start simplifying. Well, volume of nitrogen equals 1.5 divided by 3. 1.5 divided by 3 is just 0.5 litres. So the volume of nitrogen is 0.5 litres. Similarly, we can now use this part of the ratio to figure out the volume of nitrogen trichloride. Once again, volume of chlorine divided by 3 equals the volume of nitrogen trichloride divided by 2. Substituting in, 1.5 divided by 3 equals then volume of nitrogen trichloride divided by 2, or 1.5 divided by 3 is half a litre, so half a litre equals the volume of nitrogen trichloride divided by 2, or the volume of nitrogen trichloride is 1 litre. All I did there was times both sides by 2. On to the last part of question 1. This time we'll be given the volume of nitrogen trichloride being 0.845 litres. And straight away we can go straight back to our ratio. Because of Gay-Lussac's law, we know they react in simple whole number ratios by volume. So once again, the volume of nitrogen divided by 1 equals the volume of nitrogen trichloride divided by 2. Or the volume of nitrogen is just 0.845 litres divided by 2. That's a nice simple one. The volume of nitrogen must have been 0.423 litres. And last but not least, the volume of chlorine divided by 3, which is that ratio there, must equal the volume of nitrogen trichloride divided by 2. So we know the volume of chlorine divided by 3 must be equal to 0.845 divided by 2, or the volume of chlorine gas, is 3 times that, because we're timesing both sides by 3. And therefore the volume of chlorine gas is 1.27 litres. So just by going through these questions, we can actually figure out exactly how to use these sort of ratios. And please pay attention to the significant figures in each question. If you look at question 1a, 100 mils, these two zeros aren't after a decimal point, and they're not after a significant digit and a decimal point, so there's only the 1 is significant, so therefore both my answers are to one significant figure. Question B, I had 1.5. That means both those numbers are significant, two significant figures, so both answers are written to two significant figures. 1.0, that 0 is significant because it's after a digit and after a point, therefore two significant figures. Same here, this 0 is not significant, it's not after a decimal point and a number, but this one is. It's after a decimal point and a number, therefore two significant figures and two significant figures. Finally, question C, we've got 0.845, three significant figures, so both answers here have been done to three significant figures.